Today, we're going to do something pretty wild. We're going to connect the absolute bleeding edge of artificial intelligence with a philosophical puzzle that's been bugging people for almost 300 years. Yeah, you heard that right. Let's dive in.
Okay, so it all kicks off with a story you might have seen in the headlines. Way back in 2018, Amazon, they had to pull the plug on this brand new AI they built to help with recruiting. And why? Well, it turns out the AI taught itself to be biased against women. It was actually penalizing resumes that had the word women's in them, and it was downgrading graduates from all women's colleges. Yikes. So, you gotta ask, what on earth went wrong here? Was this just some simple coding bug, a glitch in the matrix? Or was it a symptom of something way, way deeper? A fundamental crack, not in the technology, but in the very logic our AIs are built on. And believe it or not, the answer is kind of hiding in an old philosophy book.
All right, so to really get what happened with that Amazon AI, we've got to go back. We need to look at a problem that's been baked into the way we think for centuries.
See, at its core, a deep learning model learns a lot like we do. It looks at thousands, maybe millions, of specific examples, let's say 10 years of Amazon's hiring data, and it tries to spot a pattern. It's trying to figure out a general rule for what makes a great candidate. That whole process, it's called inductive reasoning.
Now, check out this timeline, because this is where it gets crazy. All the way back in 1739, this philosopher, David Hume, points out a huge, glaring flaw in this exact way of thinking. And yet, centuries later, what do? We build our most powerful technology, deep learning, right on top of that same unsolved problem. It's kind of wild when you think about it.
So what is this big problem of induction that Hume was talking about? Well, it's actually devastatingly simple. He basically said, look, no matter how many times something has happened in the past, the sun has risen every single day of your life, right? There is absolutely no logical guarantee it's going to happen again tomorrow. Our belief that the future will look like the past, he said it's just a habit, a feeling, not a rock-solid logical certainty.
And this quote from 1926, man, it just nails the whole issue. Induction is the glory of science, but the scandal of philosophy. It's this incredible paradox, right? The very method that lets science build bridges and create vaccines is, from a purely philosophical point of view, standing on some seriously shaky ground. It works, we just can't logically prove why it should. So, okay, if we can't trust pure logic, where does that leave us? Well, the most common thing people do when AI gets weird is they start demanding an explanation. We want the AI to just tell us why it did what it did.
This has actually kicked off a whole field of study called explainable AI. The idea is simple. Let's get the AI to give us the best explanation for its decisions so we feel like we can trust it. In philosophy, there's a fancy name for this: inference to the best explanation, or IBE for short. Sounds pretty good, right? Just explain yourself. But, we immediately hit another snag. How in the world do we decide which explanation is actually the best one? Is it the simplest one, the one that explains the most data, or maybe just the one that feels the most right?
And this is where demanding an explanation can actually be a trap. See, we humans are suckers for a good story. We absolutely love a clear cause and effect narrative. The problem is, an explanation that sounds really good isn't always true. And even worse, what if the best explanation we get from the AI is just the prettiest sounding option out of a really, really bad bunch of choices?
So, that leaves us in a pretty tough spot. If we can't trust induction on purely logical grounds, and we can't really trust it based on an explanation, then how can we ever justify using these incredibly powerful AI systems? This is where we get to a completely different way of looking at the whole thing. What if the answer isn't to try and solve the problem of induction? What if we just sidestep it completely by changing what we even mean by knowledge? There's this really powerful idea out there called evolutionary epistemology. It basically says that knowledge isn't about finding some ultimate, capital T, truth. Instead, our ideas develop just like life on Earth, through trial and error, competition, and survival of the fittest. And this is the big mental shift. We have to stop trying to prove that an AI's model of the world is true. Forget that. The goal is to prove that it works. Its justification doesn't come from logical perfection. It comes from having survived the toughest tests we can throw at it. Okay, so how does this big, abstract, philosophical idea actually connect to the AI models running on servers right this second?
Well, this is where it all clicks into place.
So, according to thinkers like Donald Campbell, any evolutionary process, whether it's in biology or in our own ideas, it all boils down to these three simple steps. First, you need blind variation, just a whole bunch of different random starting points. Then you need selection, a way to test which of those variations actually does the best job. And finally, retention. You keep what works and you toss out the rest. Simple.
And here it is. This is the big aha moment. The way we train a deep learning model maps perfectly onto this idea of evolution. It starts with blind variation. That's the millions of random initial settings in the network. It goes through selection. That's the process of testing against data and minimizing its errors or loss. And it performs retention by updating the settings that worked and then trying again and again and again.
This just changes how you see the whole thing, doesn't it? A deep learning model isn't some kind of logician trying to deduce perfect truth. It's a hyper-fast evolution simulator. It's running through countless generations of trial and error at unbelievable speeds, all to find a solution that's fit for its environment, which is the data we give it.
And the scale we're talking about here is it's mind-boggling. This training process isn't just a few tries. It is a relentless evolutionary pressure cooker, running through millions, sometimes billions of these tiny cycles of variation and selection. And every single cycle makes the model just a tiny bit more adapted to its job.
So what this all means is that our trust in an AI shouldn't come from some belief that its model of the world is true. Our trust should come from the fact that its answers have survived the most brutal fitness test we could possibly design. It works because everything that didn't work has already been eliminated from the gene pool, so to speak.
And this leaves us with a really fascinating and kind of huge question to chew on. If our most powerful tools aren't really finding truth, but are just finding what works, what does that mean for the future of science, for the future of knowledge itself? What happens when fitness becomes more important than truth?